We are into We're into chapter 5, section 2. We're going to talk about perpendicular bisectors. Bisectors split things in half. We're bisecting it, we're splitting it in half. All right? If we have, and if you take a look at this, if we have a number line, we can make a number line, and we make this A, this B, and we say that this length here equals this length here. All right? If we were to draw a perpendicular line where it splits, wherever we would go on this line and make a dot, this length to A and this length to B would be equal. I'm going to make that B because that's a little closer. All right? Wherever we went on this line, it would be equidistant from A and B. All right? As long as it's bisecting this line, AB, and it's perpendicular, it makes it the same length. Where would you see something like that? On a house. On a roof of a house. What else? What does that look like? A tent. A tent. They make the sides of the tent equal, don't they? Yeah, and when you put that rod in the middle to hold the tent up, you try and make it as straight up and down as you can, don't you? And I'll bet you when you make it perpendicular down here, it makes these sides equal. You're equidistant from this side to this side. All right? It splits that in half. That's what they're trying to tell you here. You can say anywhere on this, if I draw a line, it's equal distance. Well, that's a bad line. All right? But it also says this. If I have a triangle, all right, where my sides are equal, and I drop a line down to here that's perpendicular to this line, it splits this line in half. Okay? So what kind of triangle is this? Isosceles triangle. If we have an isosceles triangle and we drop a line down from here and make it perpendicular, it splits this bottom side in half. All right? So there's two ways to look at it. It's dropping it down or it's raising it up. If we have two sides that are equal here, making a perpendicular line, any point on here is equidistant from the other 2 points. If we're dropping it down, we have an isosceles triangle. We drop a perpendicular down, it splits this in half, this line in half. Okay? That's what perpendicular angle bisectors are. That's a big part of what you guys have to do today. Why should I give you an assignment? All right. Take a look at the problems here. If I have these two sides these two segments are equal, I have a perpendicular line, what's x going to be? 8, right? It's the same length. It'll be equidistant. How about this one here? We have 5 and 5, so it says my segment, my hypotenuses are equal because it's perpendicular. So what do we do here? We got 2x and we got 4. Why would it be x equal 2? You'd set 2x equal to 4 and solve it, right? Because these two sides are equal. 2x equals 4, x equals 2. How about this here? We show that these two segments are equal. So any point from here over to these points have to be equal. So we would set 2x minus 3 equal to x plus 2. That's all right. All right, because I don't sit and watch the video. Well, I don't sit and watch the video. You guys would sit and watch the video. How about this one here? I've got an equal side here. I got an equal side here. I've got x plus 6 here. I've got 2x here. What would I do? Set them equal to each other and solve. Pretty much that's what we're doing on all these. All right? Let's take a look at the other page. Okay, now we don't have an isosceles triangle. What we have are two vectors that make an angle, but we're splitting it. We're splitting this with a segment, right? With a bisector. By splitting this with a bisector, it means that this side equals this side. And what we're doing is at this point, okay, first I guess before I even say that, if I have my angle and I split it out, from some point on here, I'm going to go back to my vectors and I'm going to make it a right angle at this point here and a right angle at this point here. All right? I'm making right angles from some point. That means that this segment is going to equal this segment as long as I make it right angles. This line here will equal that line there also. All right? As long as at some point I've made an angle bisector, I picked a point, I drew a line back to the vector and made it perpendicular on both of them, then I know that these segments are equal and these segments are equal. What does it also say here? It says by doing this, by angle bisecting, and these are, looks like it's all dealing with angles mostly, right? There's some sides in there. These angles are equal also. If you bisect this, then this angle equals this angle. All right? Number 9, 4x should be equal to 2x plus 20. And you solve it to figure out what x is. All right? You guys can work on all of them.